Welcome to factoring trinomials with leading coefficient that is equal to 1. Here are some examples of questions that will ask you to factor. All of these are quadratic because their degree is 2, trinomials because they all have 3 terms, and all of their leading coefficients, meaning the number next to the letter with the highest exponent, are ones. All of these are very important identifiers because if that is the question that you have in front of you, factoring will be done in a certain way. If the leading coefficient, meaning this number here, is not 1, factoring is done in a different way. So let's look at how to factor the first trinomial. When it comes to factoring trinomials that are quadratic with leading coefficient of 1, your first step is to look at the constant term, which means the term that does not have a variable next to it. In the first one, it's negative 18. And what you will do with this negative 18 is break it down into multiples. So find all the possible combinations of numbers that can multiply and make you a negative 18. So for this negative 18, the options are negative 1 and 18, because if you multiply negative 1 by 18, you get negative 18. There are more, negative 2 and 9. You can also multiply negative 3 by 6. You could multiply positive 3 by negative 6, or positive 2 by negative 9. And you can also multiply positive 1 by negative 18. These are all the pairs of numbers that multiply to negative 18. The more fluent you become with this process, the less writing of these pairs you will have to do. You should be able to quickly identify the correct one. But if it's difficult, I recommend you just write them all out. Once you are sure that you have all of the pairs that multiply to negative 18, you will now add each pair of numbers together. So let's go ahead and add. So negative 1 and 18, they will add to a 17. These two numbers is a 7. These two numbers add to positive 3, negative 3, negative 7, and negative 17. So what we have to pick out of my 6 pairs of numbers is the pair that not only multiplies to negative 18, which we know all of our 6 pairs do, but also add to the number in the middle. Our number is positive 7. So that means the pair that we need is right here, the negative 2 and positive 9. And that means that we are ready to write the factored form of this trinomial here. And the factored form is going to look like this: x minus 2, x plus 9. The order of these doesn't matter. You can write plus 9 first and then minus 2 second. It doesn't matter as long as the signs are correct. And that's it. That's how you factor it. So let's look at the second example where the constant term is a positive 24. So I have to find pairs that multiply to this positive 24, but also keep in mind they need to add to this negative 11. So we'll start with multiplying. What multiplies to 24? Well, it's 1 and 24. Let's go ahead and add them too, just to check. If you add 1 and 24, you get a 25. And you need this negative 11. So that's not your pair. 2 and 12 would be another option. And if you add those, you get 14. Again, not a negative 11. 3 and 8. Well, 3 and 8, if you add them, you get a positive 11. So we are close, but our 11 is negative. The trick to make the numbers still multiply to a positive 24, this number here, but add to a negative, would be to make the 3 negative and the 8 also negative. Because if you multiply two negative numbers, you multiply to a positive, but when you add them, you get your negative. 11. So negative 3 and negative 8, they add to negative 11, which means the factored form for this number 2 is x minus 3 and x minus 8. The last one here, we start with this 21, and we need to find two numbers that multiply to that 21. Also add to this 10. It's pretty much on the surface. It's 3 times 7. 3 times 7 is 21, and 3 plus 7. So if you add them, you get your 10, which is the number in the middle. Once you find the correct pair, you're ready to write the factors: p plus 3, p plus 7. To check if this work is correct, and I'm going to demonstrate on this third example, you can multiply the two binomials by each other and see if you end up with your original problem. So to multiply p plus 3 by p plus 7, we have to distribute twice, keeping in mind that your p's have the power of 1, because when we multiply the same bases, we add the exponents. So p times p, that's p squared, and then p times 7, positive 7p, 3 times p, that's positive 3p, and 3 times 7 is positive 21. Combine these two like terms, and you have p squared plus 10p plus 21, which is exactly the trinomial that we started with. So the next couple of examples are asking you to solve the equation instead of just factoring it. Solving equations that are quadratic, meaning they have the power of 2, can be done multiple ways, but we cannot solve them by simply getting the x by itself, and that the reason is the exact same as with the greatest common factor, is because you cannot consolidate these two x's into one since they're not like terms. So when you see x squared in your equation, you need to think factoring. This is a trinomial, and the leading coefficient of it is 1. So we will be factoring it. Do make sure that the equation has a 0 on the right side, just like with the greatest common factor equations. If it's not a 0, which my next example will not have a 0, make sure that you move all of the terms to the left side and create that 0. But ours is 0, so let's go ahead and factor. We need two numbers that multiply to 50 and add to negative 15. Those numbers are negative 10 and negative 5. So this trinomial is x minus 10, x minus 5 equals to 0. Then you take each factor separately and set each equal to 0. And then you solve by moving the constant terms. So plus 10, meaning x is positive 10, and plus 5 here, meaning x is positive 5. This is how you solve. Pay close attention to what the question is asking. If the question is asking you to solve, this is the process. But if the question only asks you to factor, you would stop at this point here and you would not set anything equal to 0. So here's another example that asks you to solve, and it's clearly an equation. It does have an equal sign. It does have x squared, so you do have to think factoring. However, it's not equal to 0. Before you start factoring, you need to take the negative 13x, move it to the left side by making it positive 13x, and you will also take your negative 40 and move it to the left side by making it positive 40. Now we're ready to factor. We need two numbers that multiply to a positive 40 and also add to this positive 13. If it's not on the surface, let's just go through the pairs. Of course, we have 1 and 40 to multiply to 40, but if you add them, you get your 41, and you need a 13. 2 and 20, we're getting closer because if you add 2 and 20, you get 22. 4 and 10, when you add, is 14. And we can do 8 times 5. 8 times 5, once you add, is your 13. So that's your pair. You break this trinomial down into x plus 8 x plus 5, keep writing equals to 0, and now we solve the equation by setting each factor to 0. For the first one, we subtract the 8, so x is negative 8. And then for the second one, we subtract a 5, so x is negative 5. This last question of this recording will ask you to factor. It does not have an equal sign, so you're not solving anything. And you may look at it and say, well, the leading coefficient here is not 1, and you're right. The leading coefficient is not 1, so we cannot go ahead and break down our negative 30 and see what numbers multiply to negative 30 and add to negative 25, simply because that leading coefficient is not a 1. The procedure I just showed only works for trinomials where the leading coefficient is 1. But what you should be able to see is that each one of these numbers is divisible by 5, and that makes that 5 a GCF. Moreover, every one of these numbers is also negative. So what if, instead of dividing them all by 5, we divided them by negative 5? Make that our GCF. So if you divide your first term by negative 5, you're left with x squared. It actually becomes positive. If you divide your second term by negative 5, that negative 25 becomes a positive 5. And if you divide your negative 30 by negative 5, that negative 30 becomes a positive 6. Once you divided all of the terms by that negative 5, we will ignore the negative 5 for the time being. We will not remove it, it's still there, but we will focus on this trinomial here, because the trinomial inside of the parentheses now has the leading coefficient of 1, and we are able to factor it further using that technique I just showed. So here I need to find two numbers that multiply to positive 6 and also add to positive 5. The numbers are 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. So the big set of parentheses will break down into two smaller sets, x plus 2 and x plus 3, and then you're going to bring that negative 5 to the front and leave it there. So be mindful, if you can take the GCF out, always do, and then check if you can factor what's inside of the parentheses even further.